Assalamu alaikum. My name is Muhammad Sanullah and I have done my mechanical engineering from the NED University. I have the experience of 5 years through the home tuitions and online tuitions. I have taught to many boards just like the O and A levels, intermediate Karachi board, IGCSE boards, and CIAE boards. Today we are going to discuss about the IGCSE Chemistry Cambridge by the Rose Mary, and our topic is the states of matter. So, in this lecture, we will know about the states of matter. As we all know that there are three basic states of matter, just like the solids, liquids, gases. But the fourth one and the new one is known as the plasma. So, what are these states of matter and how they behave? What are their properties and how they can be assumed? First of all, in order to study about the states of matter, we should know that what is kinetic theory and what is the intermolecular forces. The kinetic theory is that theory which tells about the arrangement of the molecules and their behavior. If we take an example of the, if we take an example of if we take an example of the water, so whenever the water is going to start to heat, its molecules gain energy and their internal energy is going to increase. Now, whenever the internal energy is going to increase, their collision between the molecules is increasing and their velocity is increasing. On the increase of the velocity, the kinetic energy is increased. These all are about the kinetic theory. Now, if we talk about the intermolecular forces are nothing but the internal energy which binds the molecules in the respective state of matter. Now, firstly, we will let you know about the solids. What are the solids? Solids are nothing but the atoms, molecules, and ions which are held together by the strong attractive intermolecular forces. Now, what is the behavior of the solids? How the solids behave? First of all, the solids have the strong intermolecular force of attraction. Their molecules are tightly bound to each other. That's why they cannot be compressed. Their compressibility is very negligible and zero. But when we apply the high force on the application of the high force, they can be deformed because on the application of the high force, their molecules dislocate from its mean position and they deform to a new structure. They are arranged in a crystalline structure through some definite angles. Now, if we talk about the liquids, what are the liquids? Liquids are the intermediate state between the solids and gases. What is meant by intermediate state? Intermediate state means their molecules are bound together by weak van der Waals forces and intermolecular forces. Now, when we talk about the behavior of the liquids, the intermolecular forces between the molecules of the liquids is not greater than solids and not lesser than gases. But they have the average intermolecular force of attraction. That's why they can be compressed up to the specific limit. When we talk about diffusibility, what is diffusion? Diffusion is nothing but the slow motion of the molecules from a single entity. Now let's take an example of a bath. We have a tub of bath filled with the water, and if we spill a drop of ink into the tub, so after the few minutes the whole water turns to the ink. So what is happening? This is known as the diffusion of the liquids, that the one drop of liquid diffuses slowly and the whole color of water turns to the respective color of ink. So this is known as the behavior of the liquids and diffusibility. When we talk about the gases are the gases having the weak intermolecular forces of attraction between the molecules. These are known as the So when we talk about the gases having the weak intermolecular force of attraction between its molecules and their molecules having the wider space. When we talk about the behavior of the gases, the intermolecular force of attraction between the molecules is very weaker. That's why they can easily be compressed and their molecules have accessibility to move in a random direction. The very interesting point to note that the elastic collision between the molecules of the gases is perfectly elastic. What do you mean by the perfectly elastic? The perfectly elastic means on the application of the high force, the molecules try to compress very quickly and they will collide with the walls of container. So when they collide with the walls of container, they rebound back with the same force. So this is known as the elastic collision, or we can say that the molecules of the gases are perfectly elastic. Their collision is elastic. It means to say that their energy cannot be wasted during the collision. Now what do you mean by kinetic energy? The kinetic energy is mean to say that whenever we compress, whenever we apply the force on the gases, the molecules of the gases starts to collide between each other and between the walls of container. So due to their collision, their velocity is going to increase. And whenever the velocity is going to increase, the kinetic energy of the molecule is going to increase because the kinetic energy is directly dependent upon the velocity. So on the increase of the velocity, the kinetic energy is going to increase. Similarly, the temperature is going to increase because the kinetic energy is directly dependent upon the temperature. Now how it can work? There, first of all, we have a short overview between the differences, having the differences between these solids, liquids, and gases. Now, if you talk about the solids, liquids, and gases, the simple and the easiest way to describe it is definite shape. So on the behalf of the shape, solids have the definite shape, liquids can occupy the shape of container, and gases have no definite shape. On the behalf of volume, we can say the solids have definite volume because they have a crystal structure and they have a specific structure, they have a specific volume. Either they are cubic, either they are rectangular, either they are triangular, either they have every single shape of solid has some volume. Liquids have also definite volume because whenever they go by the shape of container, so they have the definite volume of that container. But what about the gases? Gases have no definite shape, no definite volume because due to their random motion of molecules. Now when we talk about the intermolecular forces, the solids have the stronger intermolecular forces, which binds the molecules very strongly. Gases have the very weak intermolecular forces. That's why the molecules cannot be bind together. But the liquids have the intermediate intermolecular forces. Now let's look some conceptual understanding on the behalf of temperature, pressure, internal energy, and the kinetic energy of molecules. For these all, we have to take an example of ice. The ice cubes in a beaker, and we are going to supply the heat. Whenever the solid, just like the ice cube, is going to start heating, the molecules at the bottom of the surface starts to absorb the energy and their internal energy is going to increase. When their internal energy is going to increase, they start to vibrate about their mean position. As the supply of heat is continuously going, so what is happening? The internal energy is going to increase again and again, and their collision is start increasing again and again. So on the supply of a specific heat up to the specific limit, what has happened? The molecule starts to vibrate more frequently and their collision is increasing more frequently. So that's why the molecules having the kinetic energy, their kinetic energy is increasing because due to the collision and the internal energy is increasing, their velocity is increasing. And due to the velocity, their kinetic energy is going to increase. On this In this way, the molecules start to vibrate from the bottom line towards the upward. And this is known as the evaporation. What is evaporation? Evaporation is the escape of molecules